Hello everyone. In this video, I'm going to explain how to solve the Leetcode problem to find the sum of intervals between identical elements in an array. I'll go step by step explaining what interval is and then how we can approach the problem, and we will deduce the logic and build the algorithm for solving this problem. So let's get started. An interval is the distance between two indices of the same number. So let's look at an example. We have the array here, the numbers, and I've also marked the indices from 0 to 6. So let's define another array for storing our intervals. An interval is nothing but the distance between two identical elements. So here the distance is 1, 2, 3, 4. So the interval here is 4. And because this is the only other occurrence of 2, we can say that the total sum of intervals for the number 2 at index 0 is 4. Let's move on to the next element, which is 1 at index 1. We can see that the number 1 occurs at index 1 and also at index 3, and the distance between those two numbers is 2. And because these are the only two occurrences, the interval here is 2. Moving on to the next number, that's number 3, and we can see there are 3 occurrences of this number. So let's mark those here. So first one, we have the number 3 at index 2 and at index 5. The interval here is 1, 2, 3. So that's 3, and the next number is at index 6, and the interval here is 4. So the sum of intervals is 7. The next number is number 1, and the distance between this one and the only other one is 2. Next one is 2, and the distance between this 2 and the only other 2 is 4. Next up is the number 3 at index 5, and the interval between the number 3 here and the number 3 at index 2 is 1, 2, 3, and the interval between this number and this 3 here at index 6 is 1. And total is 3 plus 1, 4. Okay, the last number in the array 3 again, and the intervals are 1, 2, 3, 4 and 1. So that's 4 plus 1, 5. Now to calculate the sum of intervals, we just saw that we need the indices at which an element occurs. So we can store all the indices at which an element occurs in a hash map, and the key to the hash map will be the number, and the value will be a list containing all the indices at which that number occurred. For 2, the value stored first would be 0, then we find a 1 at index 1, then we find a 3 at index 2, then we find a 1 again at index 3, then we find a 2 at index 4, and we find 3 at index 5 and 6 again, and we have finished iterating our input array, and we have captured the data we need in the hash map. I've defined an array called result. As we iterate through the indices in the hash map, we will store the sum of intervals at that index. We'll calculate the sum of intervals for the index 0, and we'll store it in the array at index 0. And the sum of intervals for this position is 4 minus 0, that's 4, because these are the only two occurrences of the number 2. The same goes for index 4. Next up is the number 1 at the index 1, and again, because there's only two occurrences of the number 1, we'll simply calculate the difference to get us the interval, which is also the sum of intervals at index 1. Since 1 also occurs at index 3, we'll store the sum of intervals for 1 at index 3 in the result array, and that's again 3 minus 1 equals 2. Now the number 3 occurs at 3 indices, 2, 5 and 6, and the sum of intervals for the number 3 at index 2 would be 5 minus 2 plus 6 minus 2, and that gives us 7. For index 5, the sum of intervals would be 5 minus 2 plus 6 minus 5. And finally, for the sum of intervals for the number 3 at index 6, the answer would be 6 minus 2 plus 6 minus 5. Now let's try and generalize this so we can deduce the logic. Now let's say we had an array of elements, and the element n occurs at indices a, b, c, d, e and f. And now let's say we want to find the sum of intervals for the number n at the index d. So that would be the intervals between a and d. So that's d minus a plus d minus b plus c minus d plus d minus e plus d minus f, and the indices on the right side of d will always be greater than d, and the indices on the left side of d, that is a, b and c, will always be less than d. So our output would look something like this. So here we can see that we are adding the intervals on the left side of d and the intervals on the right side of d. So that is the left side here and the right side is here. We could write the same equation as 3 times d, okay, minus the sum of all the indices on the left side of d. So that is a, and now on the right side we have subtracted d 2 times from indices on the right side of d. So that becomes, so let's now try and generalize these numbers 3 and 2, and for that we can consider this list here, which is the list of indices, and let's say the number of elements in this is indicated by size. Iterating this array from A to D, D is the current index. 3 here would be the index of D. 0, 1, 2 and 3. So that's the index of D. And this 2 here is nothing but the number of elements on the right side of D. So that would be the size minus 1, because arrays are 0 indexed, minus the index of D. Now let's focus on how we can calculate the sum of the elements on the left side of D and the sum of elements on the right side of D. Okay, so here's the array of occurrences, and now let's figure out how we can find the sum of elements on the left side of D and the sum of elements on the right side of D. We can calculate the sum of all the indices and put it in a variable sum. And we can call the sum of the elements before D as prefix sum, and we calculate the prefix sum while we are iterating through this array. So when we are looking at the index A, the prefix sum would only contain A, and the next time it would contain B, and by the time we reach the index D, we have already got the sum of the elements before D. To calculate the sum of elements after D, we can simply subtract the prefix sum from the sum and also subtract D from it. So the sum of elements on the right would be the sum minus the prefix sum minus D. That would give us E plus F. So let's run this logic through an example and see what we get. So I've got another example here. So let's list the occurrences of 2, index 0, then index 2, then index 4 and index 7. So if you look at the occurrences array, our size is 4. The total of all the indices is 13. Okay, now we need to loop through this array, calculate the prefix sum as we go. I'm going to mark the indices of this array as well, 0, 1, 2 and 3. Let's also initialize the prefix sum to 0. Now let's say we are iterating this array of occurrences inside of a for loop. Our current index is indicated by I. So we'll start with I equal to 0, and the occurrences of I will give us an index. In this case, the first index is 0. So our sum of intervals would be the index, that is 0, times the position in the array minus the sum of all the elements on the left, which is the prefix sum, plus the sum of indices on the right, it is 13, minus index times the number of elements on the right. We need to now update the prefix sum and edit the first index. So in this case, 0 plus 0 becomes 0. So now I is 1 and index is 2. So our sum of intervals at index 2 would be I, which is 1, times the index of n minus the sum of all the elements on the left side, which is the prefix sum, which is still 0, plus the sum of elements on the right side, which is 4 plus 7, 11, minus index times, so in this case index is 2, times the number of elements on the right side of the current index, which is 2, and we get 9. Now we will need to recalculate our prefix sum, and for that we simply add the current index, and that makes this 2. And now we increment I and move to the next element, so I becomes 2, and our current index now is 4. So now we need to calculate the sum of intervals at index 4. So that is the number of elements on the left side of 4, which is I, times the current index minus the sum of indices on the left side of 4, which is our prefix sum, which is 2, plus the sum of elements on the right side of index 4, which is 7 here, because after 4 the only element left is 7, minus 1 times, because there's only one element on the right of 4, times the current index 4, and we get 9 again. Let's update the prefix, so 2 plus 4 becomes 6, and I is now 3, 7. So the sum of intervals for index 7 would be the number of occurrences on the left side of 7, which is I, and that is 3, times the index itself minus the sum of indices on the left side. So that is 2 plus 4, 6, which is the pre-sum, plus the sum of indices on the right of 7, which is 0 because there are no more elements after 7, minus the number of indices on the right of 7, which is 0, times the index itself, and that gives us 15. We have calculated the sum of intervals for all the occurrences of 2. Similarly, we can calculate the sum of occurrences of other numbers, but they'll all be 0 because there's only one occurrence of each of them. Okay, let's implement the solution now in the Leetcode editor. We have our test cases here, which we will run when we finish implementing. So as we need to return an array of long, which is the sum of intervals, let's define a result which will store the sum of intervals. The size will be the same as the size of the input array. We need to find all the occurrences of every element in the array. For that, we will use a hash map, and as we iterate through the input array, we will store the index for every element. Now that we have got the list of indices per element in the hash map, let's retrieve all those lists and process them one by one and calculate the sum of intervals. First, let's get the size of the list in a variable. Now we need to find the sum of all the indices in this list. We'll store the sum of the indices on the left side of the index in a variable called prefix sum. Now let's iterate through our list and calculate the sum of intervals. Firstly, let's get the current index. We need to cast I to an int because I has been defined as a long. Let's also initialize it properly using 0l. We will store the sum of intervals in the array result. Now this is the sum of intervals on the left side of the index. And now let's add to this the sum of intervals on the right side of the index. Finally, let's update the prefix sum to include the current index and return the result. I hope you find this video useful. Please do remember to like, share and subscribe. Thank you.